Hello, good afternoon. I hope you all had a good lunch. It's great to be here kicking off the afternoon session at Nordic.js. And a bit of an unusual opening for a talk, perhaps.
3, 2, 1, go! You're only supposed to blow the bloody doors off!
So, a great quote from a classic 1969 film, but why here in 2017 at a JavaScript conference? The reason being, it's very easy for us to blow the entire van up on the web when we only meant to blow the doors off, or in fact, when we only meant to do some good and to try and help people. So what I'd like to talk to you about today is some of the ways in which it's incredibly easy to blow things up, particularly for people like myself who are blind and use screen reading technology on the web. If you're not familiar with screen readers, they are pieces of software available on pretty much every platform, and they translate what most people see on screen, whether it's a touch screen or a laptop or desktop computer screen, into synthetic speech. Some typical examples: if you have an Apple device, you'll have an integrated screen reader called VoiceOver available to you. If you use Windows 10, the integrated screen reader there is called Narrator. On Windows, there are also other downloadable and sometimes purchasable screen readers that you can buy, notably NVDA, which is an open source screen reader, and JAWS, which is a proprietary screen reader. And across these screen readers, you've pretty much captured all of the people out there using technology and screen readers together. So what do screen readers do? Well, they, as I said, translate what most people see on screen into synthetic speech. So sometimes it's as simple as reading text.
ARIA Accessible Rich Internet Applications is a suite of specifications from the W3C. Knowing which specification has the information you need isn't always obvious, so this put briefly.
So you might have noticed that's a very, very robotic voice, especially if you're used to listening to some of the digital assistants like Siri or Alexa, for example. The reason being is that the more synthetic sounding voices are more responsive. They perform quicker, they respond more quickly to keystrokes. And so you'll often find that blind people, particularly those who are very accustomed to using technology, will still prefer to use those slightly fake sounding voices because they're just a lot more responsive than the better quality voices that are out there. Screen readers can also pay attention to HTML and our code. So when we put things like headings into web pages, they can recognize and respond to those. They can identify them, but also navigate by them.
Link heading level 1. Quick guide to the ARIA specifications heading level 2 link. Using the ARIA current attribute heading level 2 link.
And they're pretty good at recognizing all kinds of HTML elements, including different kinds of form field.
Tab, favorite drink, edit. T-E-Q-U-I-L-A. Tab, which type, combo box, blanco. Reposado. Jotun.
So screen readers are really pretty capable things. They can do this kind of recognition and identification at the operating system level, at the application level, and in rendered content within the browser. There's something that's quite important to understand about the way screen readers work in relation to browsers, and that's what happens when a user presses a key. And it works a little bit differently on Windows as opposed to on the Mac platform. On the Mac, what happens is that a user presses a key, and the platform listens for that keystroke. If the browser or the website, the web content, needs that keystroke, it'll pass it straight through, let the JavaScript or the application make use of that keystroke. On Windows, it works the other way around. It'll listen for a keystroke. If the screen reader needs that keystroke, it'll gobble it up and use it first, and only if the screen reader doesn't want to use it will it pass it back through to the browser and the web content. What happens on Windows screen readers is that they grab a copy of the page when it loads in the browser, and this forms something called the virtual buffer or the virtual document. And it's actually this that Windows screen readers almost always interact with. And it makes a whole lot of different things possible. So with my screen reader on Windows, if I use the left or right arrow keys, it'll read the next character in the word. If I press the up or down arrow keys, it'll read the next line or the previous line. It won't scroll the page as it would do if a screen reader wasn't running. So this model gives us great flexibility as screen reader users to be able to navigate and interact with content, but it does pose some problems. When you want to use some of the keys, like the letter keys, to actually do typing, like you would when you are entering information into a form field, the screen reader has to recognize that it needs to pass those keystrokes back through to the browser to do what they would normally do. So it flips modes. Windows screen readers change modes from their normal browse mode into what's often called forms mode, and they start letting keystrokes go back through to the browser. In other words, the screen reader ignores the keystrokes that are being pressed. So what happens when a website provides JavaScript shortcuts? It's really popular. Twitter does it, Google does it, Facebook, probably a whole bunch of other websites out there that we could name. This one we're going to use as an example is Twitter. It has a lot of really useful shortcuts for keyboard users to help you do things like view the previous tweet, next tweet, load more tweets, and they're all attached to letter keys. Now, bearing in mind that a screen reader on Windows will listen for all the keystrokes, and if it recognizes the keystroke and wants to use it for itself, it will. If it doesn't, then it'll pass it back through, and you get to use the JavaScript shortcut.
Jump to line dialog. Enter line number 1 to 954. Edit.
So with that screen reader, if we hit the J key, which on most days would have enabled the view next tweet shortcut in the Twitter website, the screen reader eats that keystroke and actually triggers a jump to line feature that's native to the screen reader. So in other words, it isn't possible for someone who's using a screen reader on the Windows platform to make use of the JavaScript shortcuts provided very thoughtfully by the website owners. The solution is actually a lot more simple than you might think. It's just make sure that when you provide those keyboard shortcuts, they are an enhancement, a progressive enhancement. Make sure that there is a way to perform that same action with a mouse, but also using the keyboard and an actual control within the interface. So a link or a button that lets you move to the next tweet or load the next batch of tweets on the page. Don't stop providing those shortcuts though. Just because a number of Windows screen reader users can't use them doesn't mean to say they aren't valuable to a lot of other people out there on the web. And actually, when it comes down to it, there are probably more keyboard-only users on the web than any other group of people out there who benefit from any kind of accessibility. So let's dig a little bit into under the hood of how screen readers and browsers work together. I mentioned that screen readers were capable of recognizing and identifying and navigating by objects right the way up from the operating system layer through to rendered content. And so if we were to look at the accessibility information about a standard platform level control, in this case it's the checkbox somewhere in the depths of Windows 10, we can see there's a number of characteristics, accessibility characteristics that are known about it. We can see that it has a role of checkbox, that's its purpose, what it does in life. It has a label, it's visually obvious, but it's also there programmatically from an accessibility point of view that says this checkbox will enable or disable a bold setting. And we also know that this particular component of the interface can be focused on with a keyboard, and it can be checked or unchecked. So we have information about this object's role, its name, and its state, both the state it's in now and the state it may be in the future. Assistive technologies like screen readers use platform accessibility APIs to access this information. And APIs like this are available on pretty much every single platform. Some, like Microsoft, actually have 3 different platform accessibility APIs to choose from. Others, like macOS or iOS, just have the one. These APIs are not developer APIs, unfortunately. They can only be used at the moment by assistive technologies like screen readers. So it's a very closed ecosystem from a web development point of view. But these APIs can be used by screen readers to query an object for its accessibility information. So if we were to create that same checkbox in the rendered content of a web page, just using straightforward, old-fashioned HTML, we discover that the same accessibility information is available when it's queried using the accessibility APIs. It has a role of checkbox, this time courtesy of the type checkbox. It has a name of bold, this time courtesy of the label element that's associated with the input using the for and ID attributes. And again, we know it's focusable and it can be checked. All of this information is provided by the browser automatically. You don't have to do anything as developers, it's just there because you've used the HTML code. If you're curious about how HTML elements, native HTML elements, map to their operating system and application level counterparts, the W3C has these documents. So most of what we do on the web these days is recreate the components that have existed in software and application interfaces for many, many years. Buttons, progress bars, sliders, panels, all of those different points of interaction. And these are the documents where you find out what does a particular HTML element expose in terms of accessibility information when I use it on the web. What happens in the browser is that when you load some code into the page, you load your document, the browser, of course, creates the document object model, something we're all intimately familiar with as developers of one sort or another. What you may not know is that the browser also creates an accessibility tree. It's a sister tree to the DOM, so they are very closely related, but they're not the same thing. The accessibility tree is the accessibility information about all of the objects in the DOM. So for every node there is in the DOM, there's a similar corresponding node in the accessibility tree, but it only contains information about that particular node's role, name, state, and any other useful accessibility information that might be available about it. There's a catch, there always is. Support is a three-layered thing in terms of accessibility for code. First, a browser has to support an element. A good example of recent years are the details and summary elements. IE and Edge still don't support it or support those elements at all. Some browsers do support them, as in that you can use them, but for a long time they didn't add accessibility support. So it meant that as developers we could use those elements, but the browser didn't recognize them in terms of the accessibility tree. So from an accessibility point of view, there was no support in the browser. Firefox and Chrome took quite a long time to get their accessibility support in order for those two elements, for example, but they've both now done a really good job of it. The third layer, of course, is that just because the browser makes this accessibility information available, it doesn't mean to say that an assistive technology like a screen reader will do the same. So all three of these things have to happen. The browser has to support an element, it then has to accessibility support that element, and an AT like a screen reader then has to be able to go and collect that accessibility information from the browser and do something useful with it from the user's point of view. So this is what happens. We load a document, the DOM gets created. That triggers an event that causes the accessibility tree to get created in the browser. And an assistive technology like a screen reader will go and query that accessibility tree. And if it's a Windows screen reader, it'll use that information to create its virtual copy of the document. Anytime something changes because we've manipulated the DOM through scripting or user interaction, that then triggers a chain of events. The DOM gets updated, the accessibility tree gets updated, that fires a change event that screen readers are listening for, and they then recognize those changes, query the information that's been updated, and make it available to users if they need to know it. So what do we do when there is no native accessibility information available? If we use native HTML elements as they're intended, all those headings, form inputs, tables, and all the rest of it, we get a lot of accessibility information for free. But we live in days of JavaScript frameworks where quite often we're repurposing divs and spans to recreate old native HTML elements, or we're creating custom components or even custom elements that don't have any native accessibility information available. And the answer comes in the form of a specification known as ARIA, ARIA to give it its full title, Accessible Rich Internet Applications. And it's a set of attributes that can be used on HTML and increasingly on SVG to polyfill missing accessibility information. So the first rule of ARIA actually is don't use it. Sounds like a great idea, but if you can use HTML or indeed SVG as it was originally intended, it's much better to do that because the browser gets to do most of the hard work in accessibility terms. It'll provide the keyboard focus for you. Quite often it'll provide the expected keyboard interaction for you, and it will expose the right accessibility information for screen readers in its accessibility tree. So think really carefully about whether you do want to start recreating a link or a button from scratch before you start down that route. If you don't have to, you'll make life a lot easier for you and a lot more reliable for users if you can use HTML as it was intended. So here's a quick example, very simple button and just a button element that when we click on it will do something. And if we want to hear what that sounds like with a screen reader.
Tab, tequila button.
It's all there. We can tab onto it because the browser's made it focusable with the keyboard. The screen reader queries the accessibility tree. It's identified the fact that it's a button. So as a user, I now know it's a button, and that means I know I can either hit the enter or the space key to activate it. And when I do, I can reasonably expect that something will happen. And it will, because we only need to use the click event on a native HTML button element. We don't need to worry about keyboard support. The browser will automatically make it work with the keyboard based on the click event. So it's really, really easy from a development point of view if you can get away with it. So sometimes there are occasions when you really need to use ARIA. Like I say, we repurpose divs and spans all the time for a whole bunch of reasons, some good and some bad. Divs and spans don't have any really good accessibility information by default. They don't have a role, you can't attach an accessible name to them particularly, and they're stateless. They're not interactive in any way, shape or form on their own, so the browser really makes no information about either of them available. So if we were to take a fake button, just pretending that we were going to make a span look and behave like a button with CSS and scripting, that would work very well visually and for mouse users. For a keyboard user, we'd have a slightly bigger problem. It's not focusable. You can't focus on a span element by default. So by just starting down this road, we've automatically broken things for keyboard users. We're starting to see the doors being blown off a little bit at the hinges here, if you like. From a screen reader demo point of view, it is possible to get to this thing that looks like a button. Screen reader users have lots of ways of navigating, not just the tab key, but this is what happens when we do.
Tequila.
We just hear the word tequila, just the name inside the button. There's nothing to tell someone who can't see this page that this is a button, no indication it can be interacted with, nothing that tells me or anyone else as a blind user that something might happen if we were to try interacting with this element. So we need to start polyfilling that information. We can use the ARIA role attribute with a value of button, and this will update the accessibility tree to say, treat this thing now as a button. In the DOM, this is still a span, but in the accessibility tree, we've updated it to be recognized as a button. We've also used tab index with a value of 0, and that makes this thing focusable with a keyboard. It just slots it into the natural keyboard sequence of a page. So as a user's tabbing through the page, they'll hit this item in their focus sequence, just as though they would if you'd used a proper button element in the first place. And the difference is quite extraordinary.
Tab, tequila button.
We're back to pretty much the same experience that we had if we'd used the button element. But how much easier just to have used the button element? And it doesn't stop there, as we'll see a little bit later. There's a lot more scripting you need to do to make that fake span button work properly with a keyboard too. With ARIA, it's really easy to break native semantics. If you use a perfectly good HTML element that says, well, hey, it's a button, and then we go and use something like the role attribute to say, yeah, but in the accessibility tree, let's pretend this is a heading. It's going to start really breaking things for people who can't see the page, because you have something that looks like a button, and you therefore would expect it to be announced like a button, and you could interact with it like a button. But because we put a role of heading and an ARIA level on it, this is what happens for a screen reader user.
Heading level 1 tequila.
So now we've got something that looks like a button, presumably functions like a button, except that a screen reader user thinks it's a heading. So you need to be very careful about when you apply new semantics or you override the existing semantics of an HTML element. Sometimes, as we'll see later, there are good reasons for doing this, but a lot of the time it's really easy to break things without really meaning to, because you're telling a screen reader user that they're looking and dealing with one thing, when actually the real object, as far as the rest of the world is concerned, is something entirely different. So you need to make things work with a keyboard. You'll have probably gathered by now that keyboard accessibility is huge in terms of accessibility. It affects so many people, not just screen reader users, but all kinds of AT users, people with mobility difficulties, whether it's a broken arm or a more permanent condition that stops them using a conventional input like a mouse. A lot of us as developers actually tend to use the keyboard more often than not because it's quicker than reaching out to grab for a mouse. So keyboard accessibility really is incredibly important. And when we create custom elements and we use ARIA to polyfill the semantics, we've also got to take responsibility for making sure that everything works with the keyboard. And it's not difficult, it can be done, but we just need to be aware that we have to do it. Sometimes it's a matter just of supplementing existing interaction. So a common design pattern I see, and one that makes me wince every time I do, but it's out there for better or for worse, is when we use a link but we repurpose it to look and behave like a button. So a link is natively focusable, so the browser takes care of that for us. But a link can only be activated with the Enter key. The expectation from users who rely on keyboards is that a button can also be activated using the space key. So for a sighted keyboard user, looking at something that appears to be a button, but trying to hit it with the space key will actually break if this is the design pattern you're using. So we need to add in some extra JavaScript that listens out for the space key as well as the Enter key in order to make this thing behave exactly like a native button would. And we just listen out for the key down event with the right key code and fire it off exactly as we would with the click event on the link. Sometimes we need to provide all interactions. So if we go back to our fake button with a span, you remember that we fixed the keyboard focusability with the tab index attribute, and we fixed the role, the semantics with the role of button, but we didn't get as far as fixing the keyboard interaction. This time we need to provide all of it. So we need to add the click event, because of course the span is non-interactive for everybody, but we also need to listen out for the key down event, and this time for key codes both 13 and 32. So we need to listen out for someone pressing the Enter key or the space key, and then we kick in with whatever the interaction is that we're expecting this button thing to do. And this is what happens when it all comes together.
Tab, tequila button collapsed. Enter, expanded. Blank. Makes me happy.
So suddenly now, with a little bit of polyfill from ARIA, some scripting to make the keyboard interaction work for everybody, this particular widget is a lot less broken than it used to be. So we're holding back on the dynamite for blowing things up a little bit here. But now we move on to a really killer way. If you really want to take out the entire van, the entire experience, and break it properly for screen reader users, this is how you do it. It's one little role attribute in the ARIA specification, and it's the application role. It says very simply that we need to treat this like an application, and so we need to limit the navigability that the screen reader user has. So when you use the application role, what you're doing is stripping the screen reader of any ability to navigate and interact with the content. As developers, we have to provide it all through JavaScript, every single last little piece of it. There are a number of other application style roles, so if you use tab list or progress bar or menu bar or toolbar, these all have the same effect. So a quick example, if we look at a tab list, so if we're creating something that looked like a set of tab panels, if we're doing this, we need to make sure that we've provided all the scripting to give the keyboard interaction.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element.
Because if we don't, that's all a screen reader user is going to get. They can't navigate, they can't move or cycle between those tabs. They literally can't do anything. They can't read that tab, they can't move to the content, nothing at all. So we need to use a technique called roving tab index that makes the set of tab panels a single tab stop. So you tab onto it, Then you use the left and right arrow keys to select the tab you want. And when you're done, you use the tab key again to move off of it again. And there's the roving tab index code example there. We just use the -1 on the tab index to make all but the currently selected tab, we take them out of the keyboard sequence. We listen for the key events for left, right, up, and down, and as they move, we let people cycle through the tabs and select the one that they want, and from there, of course, they can just use the tab key to move off and read the content. So this is the difference that it makes.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element. Reposado tab selected, use JAWS key plus Alt plus M to move to controlled element. Joven tab selected, use JAWS key plus Alt plus M to move to controlled element.
And so suddenly, because we've scripted all that tab index and keyboard focus behavior and listened out for the keystrokes and made them work in terms of moving focus and changing the content, that widget now is completely accessible to someone who can't see it, is using a screen reader, and is using a keyboard. One quick last glimpse to the future in the last couple of slides. There's something on the way that gives us enormous potential as developers to change the way accessibility works. And with it, possibly the biggest load of dynamite for blowing things up we have yet been given access to. It's called the Accessibility Object Model. It's being developed by people from Mozilla, Google, and Apple. And it's a JavaScript accessibility API. So you'll remember the APIs I mentioned before were restricted to use by assistive technologies like screen readers. The AOM will give us as developers access to this ability. And it's a 4-phase project. The first phase actually now is available in Chrome behind the flag. So it gives us the ability with JavaScript to start manipulating the information that the browser makes available in the accessibility tree. They're already hard at work on the next 3 phases of development, which will let us do even more. It'll let us add and subtract things from the tree, create virtual nodes, and query information pretty much as though we were the assistive technologies that I've been looking at all the way through this. So this is, in one hand, absolutely fantastic because it opens up the scope for providing and polyfilling accessibility information so it can keep pace with our imaginations, pretty much. But on the other hand, we have enormous potential to start really confusing things. If you think you can break accessibility with a bit of JavaScript and ARIA, just wait until you think about what you'll be able to do with this on it. So it's going to need a lot of cautious thinking from the development community as it goes forward. And that's it. How not to blow the doors off on the web for people who use screen readers and keyboards in particular. And thank you very much.
Thank you so much. Here is